In the last project, I said we could write better code to blink two LEDs at different rates. Now we're going to write that better code. We're going to use a variable to count intervals. And we're going to use the same 2 LED circuit as last time, so just boot up the Pi and open Python 3. Go to File, New Window. We're going to start fresh with a brand new program. We're going to use some lines we've seen before. Say import rpi.gpio, capitals do matter, as gpio, comma, and we'll put time. So we've now condensed our import for both the gpio module and the time module into one line. I'm going to do gpio.setMode, and we're going to say gpio.bcm. And again, this is the numbering of the T cobbler that we're using with our circuit, as opposed to using gpio.board, which uses a sequential numbering of 1, 2, 3, 4, etc. down the line. So next up, I'm going to make some new variables. It's going to look a little hectic at first, but it will make sense. We're going to go and have LED1 and LED2 as we've had in the past. I'm adding in some new variables, particularly LED1 state, which I'm setting to false, because the starting state I want is for basically LED1 to be off. LED2 state, I'm going to set to false. Now granted, just because I said LED1 state equals false, it doesn't actually make LED, the variable, set to false. LED1 state could have just as easily been just variable letter A or anything like that. It doesn't actually mean anything other than what it means to me and how I use it. Intervals is going to be my next variable. I'm going to set that to 0. It's going to be a counter variable. And I'm going to use that to count how many times I pass through a loop. And then I'm going to use a wait variable to determine how long I want to pause in that loop. And I'm going to set it to 0.25 for a quarter second. So I just want to clarify one more time here. LED1 state and LED2 state are just placeholders. Somewhere that I'm storing the value false to write to the LED1 and LED2 to set them to the state false. And I'm going to have it toggle between false and true throughout this program. So again, just by making a variable called LED1 state doesn't actually affect LED1 in any way, but we will be able to use it to change the state and toggle the state from off to on to off. So I'm going to do gpio.setup for both LED1 and LED2, but we're going to actually expand it a little bit. This isn't a mandatory line to add. I want you to get in the habit of doing this, putting initial equals 0 into this line. That sets the pin as initial value of 0 or false or off. I think 0 is just shorter to write, but you could just as easily put something else there. There are a lot of equivalent terms, like how we can use true and 1 and 0 and false interchangeably. So now that I have LED1 and LED2 set up as digital outputs, I can go ahead and start my loop. We're going to use a while loop. But unlike the infinite loop I showed you in a previous video, this one actually will have a conditional where it will end. So I want to say while intervals, that's my variable, it's currently set to 0, which is going to be increasing like a counter. While it's less than the value 40, and you'll see how it increases to the value 40, I want to do the following steps inside of this indented loop. I'm also going to add in something fun, which is going to be an if statement, but I'm not going to add it right now. I'm going to actually first show you that the while loop will include a time.sleep of the wait value of 0.25, and it's also going to take the intervals variable and increase it by 1. Now this is a longhand way to do this. I could have also shorthanded this with plus equals 1 and taken out the second repeat of the term intervals, but to help you grasp what's happening, it's taking the value of intervals and then taking that value and adding 1. And setting that as the new value. So if it's 0, it goes to 1, if it's 1, it goes to 2, and so on up the line. That's how it gets to 40 and breaks me out of this while loop, okay? Now I'm going to go ahead and add the if statement. So this is going to be basically conditional that says if intervals modulo 4, you should know modulo from the Python training video I had earlier, is equal to 0. So this means that if we do remainder division of the intervals value, every time that modulo 4 is equal to 0, meaning there's no remainder, it's going to now do what is in this indented block of code, which means that LED1 state is going to now toggle by setting LED1 state equal to not LED1 state. So if it's false, it becomes true. If it's true, it becomes false. Not is a powerful tool in Python programming. And then I want to say gpio.output LED1, comma, LED1 state. So it's now going to take LED1 and apply the new state. So if it goes from false to true, it'll turn LED1 on. If it goes from true to false, it'll turn LED1 off. I just want to point out to you that LED1 state at the start of this program is false. We declared that in our variables. The conditional of intervals modulo 4 will be true the first time through this loop because the interval value will be 0. So the very first thing that's going to happen is it's actually going to turn that LED on by setting the state to true. It's then going to pass down to the lower lines there. It'll wait for a quarter second and increase intervals by 1. And it will not change the state until intervals reaches the value 4. So this is just a starting point. I haven't added LED2 yet. This is just with LED1, and that's fine. I just want to get you exposed to how this actually works using this if statement inside of the while loop. And then we'll add LED2 next. So let's go ahead and actually save this work here. I don't want to forget to save it and give it a good name. So I'm actually going to call it interval blink. I'm going to save it, and before I actually go to run it, I want to make sure I add a gpio cleanup step here. So after the while loop, and this has no indent, we have gpio.cleanup, start and end parenthesis. Okay? Always want to make sure we have that at the end of our code so that it sets all the pins back to their default state. So now let's save it, and let's open up LX terminal and run this. Sudo python3 interval blink.py. Let's take a look at our circuit and see how this works. We're only controlling the first LED, and we're setting it up so it blinks every 1 second, because 1 second is equal to 4 of our quarter second intervals. So let's see if this worked as intended. Alright, so we have the first LED blinking at 1 second intervals. We're off to a good start. Now let's go back and add in LED2. We're going to do LED2 the exact same way we did for LED1, but we're going to set a different value for how many intervals it's going to alternate between. So basically, I'm going to go in here and put the same if intervals modulo. Now I'm going to choose 1, which may seem strange to choose 1 whenever I've got this whole operation here. It's like, hey, every time you pass through the loop, that's going to be true. Yes, that's correct. But I want to still write all this code here for a particular reason, because I want to make sure that if I want to change this, let's say I want to make it so that it alternates every 2 intervals or 3 intervals, that I have the code in place so it's easy to make that change. So although I'm doing this with modulo 1 just to illustrate the point and get the code written, it'd be easy to change it to 2, 3, 5, 7, 12, whatever I want to make sure that it alternates at a rate that I select. So what we're doing is, even though it's not the shortest way to get what we want accomplished in this specific case, it's actually the most scalable to make changes and make it better later. So while I've been talking, I've been adding in the next 2 lines to mimic the previous if statement, just replacing 1s with 2s, and now we have control to make LED2 state toggle every time it passes through the loop by making it set to modulo 1. And this double equal sign, again, you would have seen this in the Python training video. Double equal is comparison operator. It's different than whenever we used to use a single equal sign. Single equal signs set a value to a variable. So if I wanted to ask, hey, is this value equal to another value, I need to use the 2 equal signs. Just give me some clarification there in case you didn't recall that from the Python training video. Alright, so now that this is ready, let's go ahead and save this program and give this a run. So hit enter and see how your circuit works. LED 1 was blinking at a 1 second rate, while LED 2 was blinking at a quarter second rate. It's very evident to see that in the video. And so we got exactly what we set out to do. I want to show you that this is a really easy program to modify and change for different desired outcomes. And it's all right here. I can go in and change this intervals value to, let's say, 2, so it does every half second. And I could go up here and actually change the weight value if I wanted to, let's say, 0.5. So now everything about this program changes. So now LED 1 will switch every 2 seconds because I've slowed down the weight interval, and LED 2 will change every 1 second, again because I slowed down the wait interval. I'm going to put it back to a quarter though, because I like quarter seconds a little better for being able to get more finer detail and what kinds of pauses I want. Suppose I don't want this to run only 40 times through this loop, and in fact I want it to run 400 times through the loop. All I got to do is change that number. This is a very easy program to modify for different durations or different rates of blinking lights. This is much better than whenever we were just doing it all longhand like we did in the last video and putting in the gpio.output such and such LED, true, false, back and forth, and having to keep track of which one was on, which one was off. Now we can add in as many LEDs as we want to this exact structure, just like how we did for LED 1 and LED 2. We can mirror it with LED 3, LED 4, LED 5, and add in more pins. Just set them as variables up top and do the same exact thing. You could be blinking as many LEDs as you wish. So hopefully this program gives you some ideas, some inspiration, and some room to expand it and customize it. And thank you for watching this video.